In this video, we're going to talk about the Dieckmann condensation. That's a special Claisen condensation that makes a ring. Let's jump right in. So in this reaction, we're doing a special Claisen condensation. Here I have my base, my Na+, my negative ethoxide. And we know that we need to pull off a proton from an alpha carbon. So here's my carbonyl. There's no alpha carbon here, but this one has hydrogens on it. So let me draw those in. And these also have hydrogens on it. So we could attack either side. My base pulls off that proton, leaves the electrons behind on that carbon. So we have a negative aggressive nucleophilic carbon, and it's going to go do an attack. And it wants to attack a carbonyl, but instead of attacking another molecule of the same kind of compound, it's so much easier for just to reach around inside of its own molecule, backside attack this carbonyl. The electrons go up to the oxygen, they come back down, kick off my leaving group. So that makes a ring, and let's count the number of carbons in this ring. 1, 2, 3, 4, 5, 6. So there's a 6-membered ring I just made. So let's number those. 1, 2, 3, 4, 5, 6. So on carbon 6, I have a double bond O, this OET left. And on carbon 1, I have my carbonyl, OET. And that would be the final product of a Dieckmann condensation. It's just a Claisen condensation with esters, deprotonate the alpha carbon, and it attacks itself internally to make a ring, the Dieckmann condensation. Hey, think about subscribing to the channel so I can continue to help you with organic chemistry.